Imagine you are a researcher or working at a company trying to develop a new speaker system for sound cancellation outside large outdoor concerts. This would of course be beneficial to neighbors of such concerts who will be otherwise annoyed by all the noise coming from them. Now, you already have a theory, you have a model, and you have an algorithm for solving the problem. You have in fact tested this algorithm and model using numerical and lab experiments. You decide in your confidence that this will work and let's go and try it at a real concert. It fails immediately. You realize afterwards that what happened is that your parameters for the sound reflection of the ground were not quite accurate compared to what you had in the lab. In addition, nearby structures and buildings are reflecting sound back into the system that you had not incorporated in your model. In fact, the movement of trees and large groups of people are constantly changing the environment of the sound, making it so that your algorithm is getting completely confused. It's definitely back to the drawing board. What you could do is try to update the model and incorporate all the specifics you learned from this experience. But what you realize is that this may be a fruitless effort in the sense that when you go to a new venue or new location, you would have to recalibrate and re-update the model. Instead, what you realize you need to do is to find an algorithm that is robust to the imperfections in your model and the noise in the data. And this is where I come in. My name is Nicolai Riis, and I'm a PhD student here at the DTU Compute. I study and design numerical algorithms that are robust to imperfections in models and noise in data. I specifically work in the field of inverse problems, which can be characterized as problems with physical models that use a type of data fitting or regression techniques. Now, the project that I mentioned for you, the acoustic project, was in fact inspired by a real project that we acquired not too long ago. Now, I wish I could tell you that the project has a happy conclusion, but we are still working on it, and I'm still in the first year of my PhD. In fact, because it's so early, I'm also looking for additional applications where you might, if you think you have a problem which uses a type of data fitting or regression, it could be useful, where it could be useful to have a robustness to imperfections in your modeling. Then I implore you to come and ask me after the talk, and we can see if the problem fits my formulations. Thank you very much.